Our next speaker is Brandon Rhodes, who came from United States. He is an engineer at Dropbox and Chair of PyCon 2016-2017 in Portland. He's also a fabulous speaker who is excited to give a presentation in Poland for the third time. Brandon will talk about writing reusable I/O code. Hoist your I/O, Brandon Rhodes.
Resetting my timer there. I'm very, very happy to be back in Poland. I think I spoke for the first time in this country at the PyCon PL in 2011, and then under the circus tent that the magnificent organizers put up at DjangoCon in 2013. And so I seem to be kind of on an every other year schedule, and so here I am back. I'm very happy to be here. When I was very young, I never imagined that I would get to ever visit as an adult Eastern Europe and to come and see your ancient country here. America is so new. Everything here is old. So I wanted to talk about how I and my software have been beginning to learn habits that help me keep input and output code from dominating how I have to think about my code. Now, really, we run software for the sake of what's essentially called its side effects. I mean, if your program doesn't produce some output, make some difference in the world, then essentially all it's done is turned electricity into heat for a few minutes. And then once the machine powers off, all is lost, and everything you've done is gone if it didn't manage to reach outside of the machine and in some persistent way change the state of the world. Side effects are why we run software. And yet, as many of you know, it is standard for speakers to get up and routinely criticize subroutines that have side effects, code that you run that just starts going out and changing the state of the world before then returning control to you. So for example, what does this code do? Parse Host's file, you give it a path, it opens it. For each line in the file, it removes any white space. For example, each line, of course, will come in with a new line attached to it, and then prints it out. If you ask a functional programmer, any of your friends that use Clojure or something like that, what does this code do? They will carefully study it, and they'll say, it returns none. Because there's a whole genre of programmer where most of what you pay attention to is the data that comes back into the rest of your program from a routine, not the side effects that it might have accomplished out in the world on its way to computing that value, none. For those of you, by the way, who don't know this, a Python function with no return statement gives you the object none back, which is why this, which has no return statement, returns that value. Now, I'll just make it a little more interesting. Instead of just host names in a file, let's imagine that the user might want to add a little white space to separate ideas and might want to put comments in. Our code will become slightly more complicated. We now have to say if line in order to make sure it's not one of the blank lines we're paying attention to. And then we will have to ignore lines that start with a pound sign before concluding that this is a host name and deserves being printed on our output. I'll note that I actually very much dislike this code. This is if I don't pay attention, I tend to produce functions like this or routines that are sort of on a diagonal line. As they learn more and more about the situation, they keep digging themselves deeper and deeper until finally I have like 8 characters left between me and the right margin to put my code in. And it's especially problematic if your if statements don't have else's. What is the point of burning that extra room, of indenting the entire rest of the function if there isn't going to be an else, isn't going to be an alternative? So one of the first things I do when I see code like this is I swap. Instead of the if statements asking, do I want to process this line? The if statements now say, do I want to skip this line? That means they can use continue to just jump up to the next line, and to my eye, it's much clearer to have the main thought all at a single level of indentation. So I think I'm fairly happy with this now. I could invoke it with a file name, and the hosts would print to the screen, and all would be well until my project lead gives me a new requirement. We are no longer just wanting to read these host files in and print them out for the use of other tools. We now need to do a post, maybe with requests library, in order to configure some device and tell it about each of these host names. All right, obviously something's going to have to happen because the routine as I wrote it prints. It doesn't call requests.post. How can our code support both print and post from a single routine? Because right down there in the bottom, non-optional at the moment, is this print statement. What could I do to send this line, this data, to a web API instead? Well, maybe the question is misguided. How will we change our code? Why should I change the code? This is Python. It's a dynamic language. I can just leave it as a print statement, and maybe I could do this. Now, of course, I could do this directly with monkey patching by saying built-ins.print equals whatever I want, but I like using the patch routine context manager. It's now built into the standard library, since Python, I think 3.4 or 3.5 now includes mock built into the standard library. What I can do is I can get the print function, and I can just replace it with something else while this routine is running. It will think it's printing to standard out, but in fact, it will be appending these strings to a list, and when it's done running, I can go into that list and do something else with them. Wouldn't that be great? I wouldn't have to edit my code. I could even go one level behind that. If I just leave the print function in place, it will try writing to the file sys.standardout, and I could replace that with a different object, and once again intercept the output and have managed to reuse my code without even having to edit it. So a question. Would you use mock.patch to support code reuse in production? No, you would never do that. That would be terrible. You would go, edit that function, and make the code more general. If you consider patch, if you agree with me that it is an anti-pattern in production code, why are you doing it in your tests? Can you, think about it, can you hold your unit tests to the same high standard of design and coding principles that you hold your normal production code? So, when your supervisor comes and your routine that was previously printing now needs to post instead, how do you really solve the problem without mock.patch? The problem of needing not only print but post. Now here, you'll be helped if you've developed an instinct or a skill that many programmers develop in their first year or two, which is whenever you're faced with a situation where you're in an n=1 situation, your code can do one thing, handle one case. When the second case comes along, we quickly learn as programmers it's generally not worth pivoting the code to now do exactly two things. Generally, what you want to do instead is, as soon as the code needs to become more general, pivoting it to be able to handle any number of situations, not just two. I saw a great example of this need when I was teaching a course in Python about 2 weeks ago. I gave them a small CSV file, and they were adding up how many different shares of a number of stocks that they owned. And so they learned quickly they should write a loop that considers each line and keeps a running total of the number of shares purchased. Then this student noticed that the file was not all a single company's stock. Some of the shares were IBM, and some of them were Apple. So they changed so that they now had two counters, one specifically for IBM and one for Apple that had to be initialized to 0 up at the top, and then that could each grow independently. They then read a bit farther and noticed that there was a third stock later in the file, and then a fourth. And by the time I made it around, as the students were coding, they already were here and hadn't yet noticed there was a fifth and a sixth stock later in the file. And you see what they were doing. They had started with that n equals 1 situation. My code can handle one case and one case only. And when they then saw that that wasn't adequate, they instead had simply hard-coded a second case, Apple stock. Then they hard-coded a third case, Google stock. And the problem is that you wind up going in a real project as the requirements build up through code that is special cased over and over and over again. And if you've ever built one of those 20-way if statements that tries to handle everything you can think of, you know that the only winning move to this game is not to play. You want to, when possible, when you first kind of feel design pressure against a piece of code, asking it to do more than one thing, to operate in more than one situation, you want to try to learn to respond to that by pivoting over to a general solution, not a long list of special cases embedded in the middle of the piece of code. For the student in the course I was teaching, you all know when you have data coming in that needs to be collated, you use a Python dictionary. That way you don't have to special case IBM, Google, Apple, Facebook as separate symbols. The dictionary, so to speak, multiplexes between all of those different cases so that if a sixth and a seventh and an eighth stock symbol appear later in the file, the data structure automatically adapts by adding that key and keeping up with that new quantity as it runs. Now, for the parse hosts file routine I showed you a minute ago, what does the n equals 2, special casing it for a second situation, and the any-n, general situation, what do those two look like? The n equals 2 would look something like this. The code previously knew how to print. That was one situation it could function in. Well, if you are going to now also want to be able to do this HTTP post, we need to give it a switch. We need to tell it that, and in this case, I just added a single URL parameter. If the URL is the object none, we print like we used to, but if the URL is any other value, we call requests and see if the .post can succeed in order to send this host information out to an external API. That, again, backing up one, that is the n equals 2, where we just dive deep into the code, we add a special case to supplement the one that was already there. There are, however, several any-in solutions that handle any number of possible situations. And you'll be familiar with most of these if you've used Python for a few months or more. The true method is at the first line of your function. In this case, build a list. Every time you come across a host name, append it to the list, and then return the list. Leave it up to the caller to run off and do with these host names whatever it needs to. Remain agnostic about it in this routine, and you now have something that will work in any situation, whether those host names are to be saved to a file, whether they're to be transmitted across a telnet connection, whatever is going to happen to them, you're now set up and prepared. Some languages, in particular C++ or Java, if you're using design patterns, will criticize this. Went back one slide. Using a list does have one or two problems. if there are billions of host names, I know, silly for this example, but if you have a huge amount of data, you can run out of RAM trying to collect the entire data set into memory at once. And more problematic is that this also offers very high latency. If the drive that we're reading information off of takes a long time to get to the very finally end of the file, we're not going to return a single host until the entire list is done being built. This is a very high latency approach that has to completely finish this input operation before that first host name then gets printed or posted or whatever we do with it. Trying to defeat those problems, there are design patterns in use in the big heavy OO languages where you maybe will pass in a callback, maybe a bound method that you then call with each of these host names that's generated. But you know that in Python, it's much easier than that. We've baked right into the language this idea of a generator, this idea of a coroutine which keeps yielding back control to the caller. And in this case, the line that creates the list disappears, the return statement disappears. You get as far as building an expression that is that next value you want, then you just say yield. And Python takes care of the design pattern of the coroutine generator that only runs up till its next yield before control's handed back. Gosh, that's pretty. Your top level, what I'll call glue code, following Gary Bernhardt and other people who talk about architecture this way, now takes charge of the I/O. It can run a for loop across this routine either way that it wants, and then it will make the decision as to the kind of input or output, the kind of I/O that takes place, instead of the parse hosts file having to go all the way to the end and know the destination of where this information is going. The way I've thought about this recently, in order to get a picture of what I'm doing and be able to do it consistently, is that we have here hoisted our I/O, it's the old 60s computer term for input-output, all of the code that actually affects the world and makes your program worth running. We have hoisted those I/O operations up to the program's top level instead of leaving them buried down at the bottom. Initially, our subroutine was coupled to the kind of I/O that the program was originally written for. The print statement was down in the subroutine. You could not call the subroutine without print firing, so you needed to patch it or replace it if you wanted the subroutine to function in some new circumstance. With this maneuver of changing the subroutine into something that simply speaks the language of data and hands that data back, we have now hoisted our I/O up to the top level of the program, leaving the subroutine purely in charge of doing data operations. And I generally find this gives me subroutines that are far easier to use and reuse as my team comes up with new requirements than the subroutines that go ahead and perform their own I/O and thus remain very closely coupled to a single context of use. If the top-level code wants to do post, it does it. The subroutine doesn't have to change, doesn't have to be altered at all. Now, I should note, just in case you take this example home to use it to parse your hostname files, I should note that the parse hosts file routine is still very tightly coupled to I/O, because if you look up at the top line, you'll note that it still has the opinion that host names only ever come from a file on the file system. This will, of course, be ruinous as soon as someone wants to send me those host names over a socket, as soon as a configuration engine wants to hand me those host names that they've been delivered from a host configuration engine. It also, if you're going to use this as an example, it sort of behooves us to try to get that open statement out of this routine. And in general, I do this kind of automatically now after a decade or a decade and a half of using Python. Whenever I am finished with a routine and notice that it takes a file name, I tend to pivot it to just expect a live file object instead. So here's the coupled version. It has to take a path. If you want to call this, you've got to create a file on the file system or monkey patch open in order to get it working. And the solution, I usually do this in 2 steps. First, I'll notice, well, you know, the caller could open this file for me and know more about the situation. The caller knows more about the situation than the subroutine typically does. So let's have them open the file. They can be in charge. Notice the earlier version, backing up of the routine, with that with statement, opens and closes the file. So if in fact the outside code would like to keep the file open to reduce the number of I/O operations, it can't. Now I will give it that power by simply taking this file object, looping over it, and keeping it open so that the caller, who knows the whole situation, can be in charge of whether that file remains open or not. When I get to this point, I only recently have started noticing that the things here, the routine is very oddly named. I'm calling this F as though it's a file, and I in fact have parse host's file here in the name, despite the fact that I do no actual file operations on this object. What's the only thing that this object has to be? Iterable. It just has to be something that gives you lines if you do a for loop over it. And so a final step I would often take with a routine like this is to simply change that parameter name to just lines. I don't care if they're a file. I don't care if you're writing a test and are just handing me a list. I don't care if they're coming in from over a socket. Give me some lines. Give me an iterable, and I will say for each line in those lines, and I will do my processing. So this is how I actually, in my production code these days, would tend to code this up, starting again with a routine that was opinionated both about where data comes from and then where data winds up in the world. And I have hoisted through a pair of fairly simple Python operations that I think maintained the readability and simplicity of my code. I was able to hoist those I/O operations up to the top level of my code, which has more context than the subroutine does, leaving the subroutine in a position where it is more easily reusable. All I/O with this change to letting the caller open the file now lives up in my top level glue code. It opens the file, it closes it. It prints or posts or transmits the output. All of the wiring, so to speak, that connects my code with the world is up in the top level of the program. Among the patterns that have been helping me achieve this lately, first being willing to write routines, as I showed earlier, that just return data structures, as with that first version where I just built a list, filled the list, and then returned the list. That is crucial if you're not just returning a list or sequence of items, but if you're doing any kind of collation. If the result of reading over a log file is how many times you see each host name mentioned in the log file, you're not going to be able to give that answer until the end of the log file, because any of the counts, I saw google.com connected to 10,000 times, I saw dropbox.com connected to 20,000 times, those counts aren't complete until you're at the end of the file and that final count of whatever host name is mentioned in the last line has been incremented and reached its final value. So very often if you're doing any kind of data structures, if you're doing complicated collation, you do have to build a data structure. There's no way you can just yield information with low latency. But if you are operating on a linear series of items, you can use generators and iterators, as we saw a minute ago, and then I'll mention database facades in a second. On the subject of data structures, I do want to celebrate the recent Django migrate architecture. This, in fact, when I went and looked up the blog post for this talk, is Andrew here? He will be here tomorrow? You don't have to tell him I mentioned him. He might feel bad he wasn't here. But his blog post on this Django migrate that just recently came out, my database migration is now built into Django thanks to his work, His 2013 blog post starts by saying, "Last week, I was at DjangoCon EU in Warsaw, Poland, and I had a fantastic time." Good job, guys. Good discussions with fellow core developers and Django and South users to clear up some more thoughts. And the architecture, here's some links that you can follow later. The architecture he wound up arriving at was that he wound up reimagining how you might do database migrations, which often drive side effects directly, as transformations of in-memory data structures. Many, including, I believe, his own South library, many database migration libraries simply have routines where you say, all right, this model needs to change to look like that, and it goes and talks to a database. As Andrew reinvented and reimagined how how an even better South might exist in order to live in Django's own code base, he realized, why don't we defer the operations, the actual I/O, the actual effects on the world, until the very last step? Let's build in memory, using plain old objects like structs to hold data, a picture of what your database looked like every week, every month, however often you're building migrations through the history of the project. Let's build a diff routine that can look at two adjacent versions of your schema and build an in-memory little list of the database operations that would be needed to migrate. And then we can build an optimizer that looks at all 10 steps that your copy of the database is behind and can notice that, oh, this step creates a field that this step deletes. Let's just save the database the trouble and not even create that column. And so they were able to build an optimizer which batches everything together, all without ever talking to the database. When all of that is done and all of your list of operations is optimized and ready, as the very last step, that is the input to a real routine that does real I/O on your database to make those changes in the world. It's an example of something you normally wouldn't think of as something that could be purely data-driven through most of the code, because, I mean, what's more I/O specific than a database migration? But he accomplished it and made a really, really nice addition to the Django ecosystem. Generators and iterators, as we've already glimpsed, generators let you compose data processing steps that pull in items and then yield back items. You can put them together just like you would similar tools on the Unix command line. Now, there are those complex situations where your code needs to talk to the database, get some information out, make a decision, and that will drive subsequent queries to the database. Debates are still had about how best to make that code easily testable. My favorite approach at the moment, when I need to do several round trips to a database to do a large operation, is to build a facade, is to build a class that defines all the things my program needs to do to the database. And one implementation I write of the facade will just let a test give a scripted, preconceived response to test the logic in my code. Then I write a second copy that talks to a real database and has real effects out in the world. Using these three patterns in most of my recent projects, I've been able to hoist I/O, this concern of how I affect the world, up to the top level of my programs instead of having I/O be a side effect of running most of my logic that I then need to go look at after running the test to see if it succeeded. One of the problems with design patterns, if people just teach you, oh, when you see this pattern, change it this way, is you can miss a good chance to use them because you don't notice the pattern. Or I think they can sometimes inspire you to use a design pattern where it might not have a benefit, but you do see this, you see the pattern that you know you're supposed to replace. But if you just do that automatically, you're not necessarily being driven by real need. What will signal you, if that's true, to that a routine is tightly coupled to its I/O and might need rescue? My answer is that your unit tests can do this. Unit tests are most important because they maintain correctness and stop us from handing in broken code over and over. but I think they can also inspire reusability. Remember that as programmers, we tend to develop this habit that when we see a second case arise, we try not to special case it, but we try to pivot to code that can handle any number of cases. If we're developing that skill, then our test, going back a slide, then our tests can be that second use of a routine you're writing that drives you to make it general, really real-world useful general, because it has two clients it needs to satisfy instead of remaining coupled to a single use. I think that when you see patch in a unit test, it is a signal to you that the code under this test is tightly coupled. So I would offer the question, do you treat your unit tests as first-class code that deserves to be as good as your other production code, or are your unit tests second class and play by different rules? Now, Python is a dynamic language. Python lets you test and reuse code that does not deserve it. This has been very important these last 25 years because as an industry, as a practice, as a skill, we're still learning how to decouple code. We don't have all the answers yet. And in that case, a dynamic language is wonderful because it lets you treat a tightly coupled architecture as though it were parameterized. So you can go in and replace print with something else. In a dynamic language, in the end, everything is a parameter. You can replace modules, built-ins, and methods at runtimes. That's good. You can enjoy flexibility in code reuse without having to have gotten yet a perfect architecture. But it means that the language itself places relatively little pressure on your code to become decoupled and multi-purpose. Integration tests also, because they exercise your code with the coupling still in place, offer very little pressure to flip from a specific case to being clean and general and easily testable. It is unit tests that are your chance to write every routine so that it faces n equals 2 different uses from the very moment of its birth, so that it's called by 2 other pieces of code in 2 situations that it needs to think about satisfying. I end with, I guess, the big question of this talk. Are you taking advantage of unit tests to weigh upon your code architecture as the second caller that every routine has from the moment it is first written? I'm Brandon Rhodes. Thank you very much.
Thank you for a great talk, Brandon. Now we've got time for maybe 2 questions, so please go on. There is one man over there. Can I ask somebody? Or I can just go.
Hello. I would rather have a comment than a question about the open file. It's me here. Open file example, because in the the between of the first example and the final solution, you show the code that accept the file handler, and I'm afraid that sometimes it's I know that it's obvious that the example with list is awesome, but when you pass a file handler, you might end up with code that do something on the file handler and return it in undefined state. So sometimes it's for less experienced programmers, it's better to do it on place. So I would be really conscious what you are doing in the transition from the simple code to the multi-use code.
So thank you. The point. Very good point. The example where I pointed out, I kind of as a throwaway point, did say that you can, once your top level is opening the file, maybe you could leave it open and use it again in a minute. You know, I routinely run into exactly the problem we were mentioning, that my students are confused when they try to loop over the file the second time that there's nothing there, because the file pointer is sitting now at the end of the file. So I certainly agree, and when I'm teaching classes to new programmers, I never even mention that a file can be left open. I always have them use it with a with statement that does a thing with the file and then exits, and that is an important thing when working with novice programmers to help them avoid situations where they're leaving a resource open that they don't know how to seek back to the beginning of the file before reusing. Good point.
Hello, Szymon here. Sometimes when I think about Python, I think that there is a functional programming language inside Python that is trying to get out. And when I was hearing that you are talking about hoisting your I/O to the top level and about using generators and iterators, which are kind of lazy lists, then I was also thinking about it, because when someone suggests to the BDFL that Python can be thought as a functional language, he would protest, and he does some things to even, for example, removing the reduce methods to ensure everyone that they don't think about Python as a functional programming language. But sometimes when we, like you here, try to use some good code patterns, we see that we are using the patterns from functional languages. So could you comment on this thought a little?
So can I comment on the relationship of this to functional languages? This is procedural code. It steps through a series of state changes to the world where, as it steps, more and more and more output has appeared in the world, whereas something like this is more functional. Data comes in, data goes out, but it doesn't reach out and change the state of the world. And I agree with you that this code is essentially using Python as a functional language. I will say that the functional language people who use Lisp, Clojure, or one of the ML-derived functional languages, they think that all of your code is this kind of code trying to get out, as you said, is there a functional language inside of Python trying to get out? And their claim is that if the functional language people are correct, this is also somehow functional code. And when I ask them about that, they start using the word monads, and nothing makes sense anymore. So at the moment, I'm very taken with the ideas that I heard, I think 2 years ago in Gary Bernhardt's talk at PyCon, where he talked about the ideal of a procedural glue surrounding a functional core, that you want to rescue as much of your code into being data-driven code, data comes in and data goes out, as you can. You want to rescue as much as you can, but that if you try to just be completely functional like a functional language does, you wind up weird. That in the end, having side effects on the world is most obviously expressed as a procedure. And so I would say that that all of Python doesn't want to become functional. Just most of your code wants to become functional. But when I write that top level of code that actually touches databases and files, I'm very happy to have a procedural language that is honestly procedural and honestly side effecty, because that's why I write code.
Okay, Brandon will have a keynote opening the second day of our conference. Thank you again very much for your talk.